Okay, so moving on, 4.3 talks about two different triangle congruence shortcuts. One of them is called ASA, angle side angle, and what this postulate states is that if two angles and the included side of a triangle are congruent to two angles in the included side of another triangle, the two triangles are congruent. So it's saying that if A and D are congruent, and C and F are congruent, and that side that's included between those angles, if those sides are congruent, then the triangles are congruent. So ASA, you're given two angles and the side in between them as congruent to prove the triangles are congruent. So in example 1, we're trying to see which two triangles are congruent by ASA. So if I look for triangles that are congruent by ASA, I'm looking for a side that's in between a set of two congruent angles. So the two triangles that are congruent by ASA, and I've got to be careful in how I name them. I'm going to name them triangle GHO. It is going to be congruent to triangle CAT. And the reason I named it in that specific order is because G has a single marking, C has a single marking, H has two markings, A has two markings, O has 0 markings, T has 0 markings. The reason those triangles are congruent by ASA is because angle G is congruent to angle C. Okay? Angle H is congruent to angle A, and HG is congruent to AC. So this is that angle side angle because HG and AC are what we call included angles between the two congruent, included, they're not included angles. Sorry, they're included sides between the two congruent angles. My bad. So they're included sides between the two congruent angles. The reason this triangle FIN wouldn't be congruent by ASA is because the congruent side that's marked is not included between the two angles. So the included side has to be between the two angles. So ASA is the next shortcut. After that, there's a theorem, or a shortcut, and it's the angle side theorem. This one's a little bit trickier to understand. So this says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So we're looking at two angles and a side that's not in between them, and then two other angles and a side that's not in between them. So if I look at example 2, and I know I'm not giving you a ton of examples, but example 2, these triangles are congruent, and I would say yes. The reason being, they will be congruent by AAS, and it's us being able to say that this angle that I marked and this angle that I marked are congruent. So I'm going to name those angles. I can say that angle PRS is congruent to angle SRI because they are vertical angles. Okay, those are vertical angles. What that allows me to do is that allows me to say the triangles are congruent by this AAS because two angles and a not us write the word and, that's lazy, and a non-included side are congruent, okay, are congruent to the corresponding. To the corresponding angles and non-included side of the other triangle. Now, I know that this is more writing than we've done since we've done conditional statements and all that stuff. You're not going to have to do as much explaining. More what I'm going to care about right now is if you're able to identify the shortcuts. So you're going to get some practice in that. You're going to get a lot of practice in it, actually. So this is kind of rounds out the other shortcuts, the other theorems. We will cover these again in our next class a little bit more in depth so that you can understand these a little more deeply. So right now it's just about recognizing the theorems and how to tell which ones are which. All right, so that's what your practice is going to kind of entail.